sun's energy is what gives us light, food, warmth, and the ability to live on Earth. Without the sun, the existence of life in this galactic universe would cease to exist. Hey there, and welcome to Weatherwise. I'm meteorologist Brittany, and thank you for joining me today. We're talking about the sun. The sun is 4.5 billion years old, and we're currently at the peak of an 11-year cycle in a solar maximum. Today, we're going to discuss what that means to Earth and our solar system. Let's describe the sun first. The sun is a big ball of hot gases. The gases are converted into energy in the sun's core. The energy moves outward through the interior layers into the sun's atmosphere and is released into the solar system as heat and light. What is the sun composed of? Well, the sun is about 72% hydrogen and 26% helium. The rest trace amounts of oxygen, carbon, nitrogen, magnesium, iron, and silicon. It is the process of nuclear fusion that converts hydrogen into these other elements. These elements are created in the sun's core. The temperature of the sun in this layer is about 27 million degrees Fahrenheit, or 15 million degrees Celsius. Hydrogen atoms are compressed and fused together, creating helium and a lot of energy. This process is called nuclear fusion. Nuclear what now? Nuclear fusion. It is an atomic reaction in which multiple atoms combine to create a single, more massive atom. The resulting atom has a slightly smaller mass than the sum of the masses of the original atoms. Nuclear fusion requires extremely high temperatures on the order of tens of millions of degrees Celsius. In addition, an intense attractive force such as gravitation of the magnitude that occurs in the center of these stars. Scientists can generate the high temperatures and forces required to produce uncontrolled hydrogen fusion, which is the most notable example being the hydrogen bomb. Now, let's discuss solar flares, sunspots, and the cycle of the sun. Sunspots are magnetic storms on the sun's surface. Solar flares are intense flares of radiation that come from the release of magnetic energy associated with the sunspots. The National Oceanic Atmospheric Administration ranks these flares using 5 categories from the weakest to strongest. There's A, B, C, M, and X. Each category is 10 times stronger than the one before it. And within each category, they can be ranked from 1 to 9. For example, A1 is the weakest flare. And while they go up to 9, according to NASA in 2003, the most powerful flare was recorded as an X28. Did you know that flares can travel at different speeds depending upon their intensity? From 40 hours to 12 hours, even 8 minutes before it reaches Earth. Now let's talk about the solar cycle. First of all, what is it? The solar cycle is described as the number of sunspots increasing and decreasing over time in a regular, approximately 11-year cycle. The exact length of the cycle can vary, and more sunspots mean an increased solar activity, which means more flares. A solar minimum was hit, according to NOAA and NASA, from 2007 to 2009. In fact, from 2008 and 2009, there were almost no sunspots. In 2010, the sun's record-breaking sleep finally ended, which now is entering a peak or solar maximum this year. When it arrives, the peak will bring more solar flares. What does this mean for Earth and our weather? Well, solar activity affects the Earth in many ways, some which we are still coming to understand to this day. An active sun can generate geomagnetic storms that can damage 21st century satellites and other high-tech systems in space, such as a GPS navigation system, to power grids, to even air travel. A quiet sun usually means weaker solar winds, which may allow more galactic cosmic rays into the inner solar system. Times of depressed solar activity seem to correspond with times of global cold temperatures. For example, during the 70-year period from 1645 to 1715, few, if any, sunspots were seen, even during expected sunspot maximums. Western Europe entered a climate period known as the Maunder Minimum, also known as the Little Ice Age. During 2012, on the other hand, the sun was more active, unleashing some sizable X-class flares and many M-class flares. The sun's flares interact with Earth's magnetic field, which then creates the lights in the northern and southern poles, where the magnetic fields are their strongest on Earth. This is the explanation of why we have seen some of the most spectacular displays of northern lights in years. Now, if we lose the sun, we lose our source of energy. It takes extremely high temperatures to create that nuclear fusion process. So without the sun, well, we lose some of our living organisms, such as plants. But could we recreate this type of energy? Thanks for joining me on this week's Weatherwise About the Sun. I hope you learned something. I know I sure did about this extensive research. For additional weather stories, you can follow me on Twitter at HMWeatherNews. You can also like our page at Facebook/HMTV6, and you can also go to Herald-Mail.com for further updates. Until next time, stay weather-wise.